The discovery of the new moon discovery in science often comes with a mix of serendipity, persistence, and technology meeting at the right moment. The story of the new moon orbiting Uranus, revealed through the eyes of NASA's James Webb Space Telescope, embodies all three. For centuries, Uranus has hidden its faintest companions from view. And only now, thanks to Webb's unparalleled sensitivity, have we peeled back another layer of its secrets, faint signal in the darkness. In 2023, astronomers turned Webb toward Uranus to study its rings, atmosphere, and moons. These observations were part of a broader program to understand the ice giants. Uranus and Neptune, two of the least explored planets in our solar system. Webb's instruments were expected to deliver clarity unmatched by any previous telescope. As images began to stream back, Uranus appeared not as a distant dot, but as a richly detailed world. Its bluish-green atmosphere glowing in infrared, its delicate rings visible in astonishing clarity, and its larger moon shining faintly around it. But tucked among these familiar sights was something unexpected. Careful examination revealed a tiny point of light that seemed to shift slightly between exposures. At first glance, it looked like a background star common in the crowded fields of space. But this point was behaving differently. Unlike distant stars, which remained fixed, this faint glow appeared to move in step with Uranus, orbiting alongside it. Astronomers realized they were looking at something new, a previously undiscovered moon. The challenge of spotting small moons, telescopes on Earth have struggled as well. Even with modern adaptive optics, the glare from Uranus overwhelms faint companions nearby. Small moons, only a few kilometers across and covered in dark material, reflect very little sunlight. From Earth's perspective, they blend into the background stars. This is where Webb's infrared vision changed the game. Instead of relying on reflected sunlight, even tiny moons emit a trace of heat, and Webb's instruments were sensitive enough to pick it up. In essence, Webb allowed astronomers to see in the dark, revealing what had been invisible for decades. But spotting a faint dot is only the first step. Astronomers needed to show that it was bound to Uranus by gravity, not just a coincidental alignment of a background star. To do this, scientists compared multiple Webb exposures, taken hours apart. The mysterious object shifted its position in exactly the way expected for a moon orbiting Uranus. It wasn't drifting independently across the sky as a distant asteroid would. Instead, it moved in harmony with Uranus itself. Further analysis confirmed the trajectory. The object was indeed a natural satellite of Uranus, circling the ice giant like its siblings. With that, a new chapter in the story of Uranus's moons began. How big is the new moon? Based on its brightness and thermal signature, astronomers estimate that the new moon is only a few kilometers wide, likely between 5 and 10 kilometers in diameter. This makes it one of the smallest moons in the Uranian system. Its size explains why it escaped detection for so long. Compared to Titania, Uranus's largest moon at 1,578 kilometers across, this new body is a mere pebble. Yet even small moons can play outsized roles in shaping planetary systems. By tugging on ring particles with their gravity, they can carve gaps, maintain structure, and even influence how rings evolve over time. Where does it fit among Uranus's moons? Before Webb's discovery, Uranus was known to have 27 moons, named after characters from Shakespeare and Alexander Pope. These moons fall into three main groups: large classical moons, Titania, Oberon, Umbriel, Ariel, and Miranda. Icy worlds hundreds of kilometers across, with varied surfaces and geological histories. Small inner moons, tiny irregular bodies orbiting close to Uranus. Distant irregular moons, captured objects in wide tilted orbits, likely snared from the Kuiper Belt or beyond. The new moon belongs firmly in the second category, a small inner moon orbiting close to the planet. Its presence suggests that Uranus may have more of these faint companions waiting to be found. Why this discovery matters at first glance, one might ask. Why does a tiny moon matter? After all, it's just a rock a few kilometers wide, circling a distant planet. But in planetary science, even the smallest discoveries can reshape our understanding. Here's why this moon is significant. Clues about formation. Small moons are remnants of the processes that built planets and rings. By studying them, scientists can learn how Uranus's system formed and evolved. Dynamics of rings. Shepherd moons play a vital role in maintaining planetary rings. This moon may help explain some of the structures seen in Uranus's rings. Population estimates. If Webb can find one new moon, there may be many more. Discovering them would refine models of how many small moons ice giants should have. Testing Webb's limits. The fact that Webb detected this object demonstrates its incredible sensitivity and opens the door to even more discoveries in the solar system. In short, this tiny moon is a proof of concept showing that we can still discover new members of our solar family, even in places we thought we understood. The human side of discovery beyond the science, there is the human thrill of finding something new. For the astronomers who first spotted the faint dot in Webb's images, the moment must have been electric. Imagine spending years designing observations, calibrating instruments, and combing through data only to realize you are the first person in human history to see a new world. Even if that world is no bigger than a city, it is still a world, a place that orbits the sun, has existed for billions of years, and now has a name, an identity, and a story to tell. Discoveries like this remind us of the romantic side of astronomy. The idea that exploration is not finished, that there are still frontiers to cross and new horizons to reach. Comparisons with other discoveries? This isn't the first time faint moons have been discovered around distant planets. Jupiter, Saturn, and Neptune all have dozens of small moons, many discovered only in the past few decades, thanks to improved telescopes. In fact, Saturn currently holds the record, with over 140 confirmed moons, many of them tiny. What sets Uranus apart is its relative neglect. Since Voyager 2's flyby in 1986, Uranus has had no dedicated missions. Observations from Earth have been sparse, leaving gaps in our knowledge. Webb's discovery is a reminder that Uranus is just as dynamic and complex as the better-studied gas giant sand, that it deserves more attention. The path ahead, the discovery of this new moon, is just the beginning. Astronomers plan to continue monitoring Uranus with Webb, tracking the moon's orbit more precisely and searching for additional companions. Each observation adds to our map of the Uranian system, filling in details that have remained blank for decades. Looking further ahead, proposed missions like the Uranus Orbiter and Probe, recommended by NASA's 2023 Planetary Science Decadal Survey, could revolutionize our understanding. Equipped with modern instruments, such as spacecraft could study Uranus's moons up close, perhaps even landing on the larger ones. By the time such missions arrive, Webb will already have laid the groundwork, identifying targets and raising questions that future explorers will answer. A reminder of cosmic humility in a way, the discovery of a new moon around Uranus is humbling. For all our technology, for all our centuries of astronomy, we are still finding new neighbors in our own backyard. The solar system is not a static place we have fully mapped, but a dynamic environment filled with surprises. If a moon, a few kilometers wide, can remain hidden for so long, what else might still be out there? More moons, rings? Even undiscovered dwarf planets lurking in the Kuiper Belt. Webb's success hints that the age of discovery is far from over. From a dot to a world, the new moon around Uranus may never be a household name like Titan or Europa, may never host a lander or a probe. But its existence enriches the story of our solar system, transforms what was once a blank patch of sky into something tangible. A world with its own orbit, its own history, and perhaps even its own small role in shaping the destiny of Uranus. All from a faint dot of light, captured by the golden eye of a telescope a million miles from Earth.